I'm afraid this is going to look sideways on your computer screen, but I don't think it will. I think it'll be okay. So we are at the top of page 784. We are looking at theorem 11-5-3. And this time we're looking at two tangents or secants or chords that intersect outside of the circle. Actually, two chords cannot intersect outside the circle, so forgive me for that, because they don't go past the circle walls. So we're looking at two tangents meeting outside the circle, which would be like that. We're looking at two secants meeting outside the circle, which would be like that, or a combination of a tangent and a secant that meet outside the circle, which would be that. So this time we have a new formula. To find the measure of that angle, instead of adding the two intercepted arcs that are created, we're going to subtract the smaller one from the larger one, but we're still going to divide by 2. So in order to find the measure of angle 1, which is angle C, we're going to say the bigger arc that was created, which is arc AD, so the measure of arc AD, minus the smaller arc AD minus BD divided by 2 or multiplied by 1/2, and that's going to give us the measure of the angle. Same thing here. For the measure of angle 2, we would say arc EHG, because it is a major arc, minus minor arc EG divided by 2 or multiplied by 1/2, and that's going to give us our measure. One more time over here with two secants. The measure of arc JN minus the measure of arc KM divided by 2 is going to give us the measure of angle 3. Okay, I'm going to turn the phone. Let's come down and look at example 3. Find the value of x. So this is just like what we did. This one is with a tangent and a secant. And so what we have to do is, when they meet, they intersect outside the circle, which means we say larger arc minus smaller arc divided by 2, or larger arc minus smaller arc multiplied by 1/2. And when we do that, 174 minus 98 divided by 2 equals 38 degrees. So angle P is 38 degrees. Let's look at letter B. Same thing, but this one we have to do another step. Okay, sorry, I got distracted because of something scary that my husband is doing in the yard. He has his Jeep hooked up to a tree trunk that he's trying to pull over, and that is a little terrifying. So, sorry for the distraction. I'm trying to make sure he's still alive out there. Okay, all right, the whole circle, of course, is 360 degrees. We are not given the measure of the major arc, which is EHG. We're only given the measure of the minor arc, which is 132. So we need to know this major arc in order to be able to solve for this angle. So I said whole circle, 360 degrees, minus the 132 that is that part or that arc, and that makes this arc 228 degrees. Then I used my formula. I said 228 minus the smaller arc, 132, divided by 2, and that gives me an angle of 48 degrees. All right, I think y'all are going to find that pretty easy. We're not going to look at the check it out on that, but we are going to look at this cool biology program. This cool biology problem. When a person is farsighted, actually let me put the camera on the picture. I'll read it to you and you can look at the picture. When a person is farsighted, light rays enter the eye and are focused behind the retina. That's happening back here. In the eye shown, light rays converge at R, right there. If the measure of PS is 60, I've labeled that as you can see, and I should have called that arc PS, and the measure of arc QT, which is this arc right here, which I couldn't label easily, so I wrote it right there, is 14 degrees. What is the measure of angle PRS? So this is just like the problems that we just did. These are two secants creating this angle outside of the circle. So we're going to say larger arc minus smaller arc divided by 2 equals 23 degrees. Okay, moving on. Let's go to page 785. We are almost done, and I think we're going to squeeze it all into this one last video. We are at the top of 785, and what I'm looking at is really just a review of all the things that we just talked about. So I'm going to show you, I'm trying to figure out which part I am going to show you. I think I'm going to stick to the diagrams for you. You can be looking in your book as well, but I'll read it. If the vertex of the angle is on the circle, like an inscribed angle, or the angles that we've studied today that are created by tangents and secants, or tangents and chords, or was there anything else? No, tangents and secants or tangents and chords. Then the angle is going to be half the measure of the intercepted arc. So this angle is going to be 60, this angle is going to be 100. I think y'all have a handle on that. Let's move on to the next one. If the vertex of the angles are inside the circle and created by two secants, it's going to be half the sum of the intercepted arcs. So this time we're going to have to look at the arcs that were created by the two chords or the two secants, and we're going to add them and then divide by 2. Remember, 1/2 of one arc plus the other arc, or arc plus arc divided by 2. So this one is 86 plus 45 divided by 2, which is 65. And if the tangent and secant, or tangent and chord, or two tangents meet outside the circle, as in this case, then the angle is going to be half the difference of the measures of the intercepted arcs. So in this case, it's larger arc minus smaller arc divided by 2, or multiplied by 1/2. Larger arc minus smaller arc divided by 2. And that's how you get these answers. All right, let's look at two last problems. We are going to look at example 5, finding arc measures, and we're going to find the measure of AF in here. All right, finding the measure of arc AF. I've done a lot of work in here, so I've got to figure out what I did. Sorry, y'all bear with me just a second. Okay, I started just trying to glean information. So what I did first is I knew they had given me this angle for a reason, and I knew that this angle was going to be 1/2 because it's sitting on the circle. It's going to be 1/2 of its intercepted arc. So I said its arc is going to be 220. So the arc from A to C, it measures 220 degrees. I then wanted to find out what arc AD was. So AD was going to be AC minus DC, or 220 minus 160. And that gave us a measure of 60 degrees. Once I had, they had also given us FB. So once I had FB, BD, and DA, I simply could say the whole circle minus 1, 2, 3 arc measures, and that gave me 92 degrees. So I said 36 minus 48 minus 220 equals 92. There are other ways that you could have done that problem. That's just the way that I did it, but 92 degrees is our answer. All right, let's look at our last two, check it out, and then we will be done. Find the measure of LP. Oh, there's only one, check it out. Okay, finding the measure of LP. Well, I knew that LR equaled 100. That's what I've marked here as LR right there. Let's see, what else did I figure out in here? I knew that this angle, 26 degrees, because it was outside the circle, was going to be arc MS, the larger arc, minus arc PR, the smaller arc. So I knew that I could find, divided by 2. So I knew I could find PR. I set it up right here. 26 degrees is going to equal the 80 degrees minus the unknown arc over 2. So I set up my same equation, but this time I had an unknown in the formula, not in the answer. So I multiplied both sides by 2 to get that off the bottom of the fraction. That gave me 52 equals 80 minus arc PR. Then I moved PR to the other side to get it positive, and I subtracted 52 from both sides. Arc PR equals 28. 28 degrees. You can see that I've written that in here. The question wants to know what the measure of arc LR is. Now we have all the pieces of the puzzle to figure that out, because we have LP. Wait, I'm sorry. We want to know what LP is. Forgive me, I don't think I said that right a while ago. We want to find what LP is. We have the whole LR minus the little 28. So that's 100 minus 28 equals 72. So arc LP equals 72. All right, I hope that was helpful. That's the end of that video, and I hope your homework goes well.